Hello students, welcome back to this new session of mathematics class for second semester students. Here I'll be continuing the discussion of non-homogeneous linear differential equations. In this part, I'll deal with the non-homogeneous differential equations with PI of type 3. Now, what do I mean by this PI of type 3? That is particular integral of type 3. So, in my first session, I have already explained you people have only 3 types of PIs as concerned to non-homogeneous differential equations. So, the last part was remaining, that was a linear differential equation. For instance, just consider A naught y double dash plus A2 y dash plus, A1 y dash plus A2y is equals to phi of x. So as you see, if this phi of x is not equal to 0, we say it is a non-homogeneous differential equation. Now for here, if it is e to the power x, ax, we have seen how to do, how to work with the problem and how to get the solution. We have learnt it. We also have seen when it is cos ax or sin ax or cos ax in place of phi of x, what you must do, what should be the steps to follow to get the solutions. We have seen this in my previous 2 sessions. Now, coming to the third type, wherein this phi of x appearing as a polynomial in x, appearing as a polynomial in x, as a polynomial in x. Okay, so directly I will start with the problems. Okay, so I request all the students to follow the solution, take a pen and a paper and start working for the problem with me. So when it comes to PI, I'll let you know. However, YC part, it's going to be the same. You'll have learnt it a number of times in many problems, it's going to be the same. But when it comes to YP, that is particular integral, and when you have phi of x as a polynomial in x, then what you must do, we will see, okay, in this example. Okay, so let's start with the problem. So here I have one problem for you. This is first problem in polynomial type. Take this as y double dash plus 2y dash. I hope this is seen. Okay, y double dash plus 2y dash plus y is equals to 2x plus x square. Y double dash plus 2y dash plus y is equal to 2x plus x square. So how will you solve this kind of a problem? Okay, now this part you have, obviously you know how to do with this. So this is nothing but d square y by dx square. Let's start with the solution. All of you, please solve with me. It's not. Okay, so it is nothing but d square y by dx square plus 2 times dy by dx plus y is equals to 2x plus x square. Is it? Now I told you to replace every d by dx by capital D. So it becomes d square y plus 2dy plus y is equals to 2x plus x square. And this all steps I think you all remember very well. Okay, so I am proceeding to write the auxiliary equation. So do follow. So it is d square plus 2d plus 1 of y is equal to 2x plus x square, same as the previous problems. Okay, so let's go for our auxiliary equation AE, which is nothing but m square plus 2m plus 1 is equals to 0, right? So this is our auxiliary equation. You are going to consider the bracket, replace every d by small m and equate that term to 0. You are going to leave this y and leave this the right hand side. Just consider the bracket. Yes, replace every d by m and you get an auxiliary equation like this. So these steps are very clear to you. You'll have solved a number of problems on this. Okay, let's work for the roots of this equation. As you see, it is m square plus 2m plus 1. It's nothing but m plus 1 the whole square is equals to 0. What do you say? So you can write this as m plus 1 is equals to 0. M plus 1 the whole square is 0 means you can just consider one bracket out of it and consider m plus 1 to be 0. Right? So what do you get m as then? M is equal to minus 1. See here, out of two brackets, you had considered only one bracket and said m plus 1 is equal to 0. But again, there is one more bracket saying you m plus 1 is equals to 0. Right? So you have m is equals to minus 1 twice. M is equal to minus 1 twice. Is it? So now, yes, we are having m is equal to minus 1 comma minus 1 as the two roots of this auxiliary equation. So here the roots are real and they are equal. And you'll have studied this rule. Whenever the roots are real and equal, how do you write yc for that? How do you write yc? Yes, you consider one constant c1. You don't take any x, nothing. Just consider one constant c1 plus xc2 into e to the power, take that in the bracket because it has been repeating twice. So you must have two terms in your bracket, c1 plus xc2 into e to the power minus x, because e to the power value of the root, it is minus 1 into x, that becomes minus x. So this is your yc for this problem. Okay, up till here you will have learnt in previous classes also. It's not a big deal. Okay, so let's work with yp now. Now I have repeatedly said in my previous sessions, also in my class, how to get your yp. Once again, where you had written auxiliary equation, from there only take that equation, okay, and separate your y from that equation. So your particular integral pi represented as yp, you have to separate it from this equation, your y. Okay, so what is your y from this equation? It is 2x plus x square divided by d square plus 2d plus 1. Okay, now all of you please pay attention. This is a new kind of problem for you. Okay, so please pay attention here. Okay, so the basic rule here, okay, step by step, you can keep your pen and paper aside now. Just listen to me carefully. Just follow the steps properly. Up till here, it was known to you. It's not a big deal. Now here, from here, please pay attention everyone. Here what you are going to do, see the numerator. You are having 2x plus x square. Okay. Rewrite this numerator in the descending powers of x. Okay. So what do you mean by the descending powers of x? It means the highest power of x should come first, then with the lower power of x, right? So as you see, x square is the highest power present here for x. So that should be written first, x square. Plus, next, the term having x. Yes, there is a term having x plus 2x, right? So x square plus 2x or 2x plus x square is one and the same. So we are writing this numerator in the descending powers of x. This is your first rule. Okay, no matter what is the numerator here, you are going to rewrite the numerator, which is a polynomial in x, rewrite the numerator in the descending powers of x. Okay, divided by. Now look what you have to do in the denominator. Okay, you should pay attention here also. See, the starting term is d square plus 2d plus 1. Here I will do the reverse case what I did in the numerator. What is that? I will write the denominator in the ascending powers of d. Okay. So ascending powers of d means what? First, which does not have d only. Next, a single d will appear. Then d square will appear. Then d cube will, and so on. So here as you see, any term which is where there is no d appearing, yes, here. So this value 1, it doesn't have any d with it. Okay. So write that first. 1 plus. Next, the term appearing with d, okay, that is 2d. Next, then obviously the next term will be for d square. So which is the same again, 1 plus 2d plus d square is nothing but 1 plus, yes, d square plus 2d plus 1, one and the same, right? So what we are doing, we are writing the numerator in the descending powers of x, please pay attention, and writing the denominator in the ascending powers of d. After this, we simply go by our division method. Okay. So let's go for division. You'll have learned division in your previous classes already. But when it comes to d, it is also very simple. Nothing to worry. Okay. So it is 1 plus 2d plus d square. Let's go by division now. Here we are dividing this numerator with this denominator. Okay, so you should multiply. Look at this. The first term you are having is x square, right? You should multiply this one a term so that you should get x square. Look at this. This is 1 over here. Okay, so you should multiply something with this one so that you should get x square. The only thing which you can multiply to get x square is nothing but x square only, right? Because x square into 1 results in x square. So x square into 1. So you are going to write that x square over here. X square into 1, x square. Got it? X square into 1, x square. Why we are taking x square over here? Just see this first term. Okay, you should and see the first term here. Okay, here it is 1 and here it is x square. Okay, you should multiply a term to this one so as to get x square which is written here. Okay, so what we are doing? We are multiplying x square to get x square from 1. Okay, so now multiply this x square with this one, so you get x square. Write it below here. Okay, below this x square. Then multiply this x square with this 2d. It is something like 2 times d of x square. Did you get it? See, you are multiplying this x square with this 2d. 2 times d of x square. 2 times d of x square. Now what is d? D is nothing but d by dx. D is nothing but d by dx means what? It is 2 times derivative of x square. What is derivative of x square? It is 2x, right? So multiply it together, so you get 4x. Is it not? Just see, I have done a small work here for this. Just see, you are multiplying this 2d with x square. So you get 2 times d of x square. Derivative of x square is 2x. D is nothing but d by dx. I have told you a number of times. So it becomes 2x into 2. That results in 4x. Write it below this term. Plus 4x. Is it? After multiplying. So each of this term written here, you have to multiply with this. Okay. Now you are done with 1. You are done with 2d also. Now you should multiply d square with x square. So d square of x square it is. D square means it is second derivative of, yes, x square, right? D is nothing, d square. You have written it already. So d square is nothing but d square by dx square, right? So d square of x square is nothing but second derivative of x square. So first derivative will be, if you simplify this, first remove 1d, it becomes 2x over here. Again remove another d here, it becomes simply 2. Is it? Just see, d square of x square, second derivative of x square. First derivative will be 2x, second derivative will be 2. Is it not? So plus 2. Whatever you get, you write it here. Done? Now draw a line like this. Change the signs of the below terms. Now add x square with this minus x square. Both will get cancelled. Add these two, you get minus 2x. There is no constant term here, only minus 2. See, you are changing the signs here. You are subtracting. Okay. So now the same whatever you had done previously. You see what you did. You say you took this x square and you thought, or you tried to get one term multiplying this one so as to get x square, right? So that you multiplied with x square and you did the whole stuff. Now here you have got 2x, okay, and you have got 1 over here. You should multiply to this one a term so as to get you should get minus 2x. So what is that term? Obviously you should multiply with minus 2x. Is it? Minus 2x into minus 1. Sorry, minus 2x into 1. It becomes minus 2x. Is it? Now again multiply minus 2x with 2d. So it is, yes, first you have to multiply minus 2x with this one. So you get minus 2x. Then minus 2x with this one, minus 2x. Now you are multiplying this 2d with minus 2x. So 2d of minus 2x. It will be something like this. Now 2 into 2 and minus sign over here. So it becomes minus 4. Derivative of x, 1. So you result in minus 4. Is it not? Just see. Minus 2 times derivative of minus 2x. So it will become, this is already been done. You are not going to do anything to this x square. It has already been done. You have already multiplied each of the term present here. You have simplified and you have written this. Now the term you have to multiply is minus 2x. So you are only considering this. Don't again consider this. Okay. So only multiply this term with each of the terms written over here. Okay. So you get minus 4. Again take a line like this. Now, but before going to that line, you have to even multiply this minus 2x with d square. So what is that? It is d square of minus 2x. Is it not? Now, first derivative of x you can take, minus 2 you can take common, the constant, you can take it outside. So, you get d square of x. First derivative will be 1 for x. Second derivative for x will be 0. So, need not write that second derivative for that 2x, okay, because it is appearing 0. You stop it there only, that is you have to stop till minus 4 over here. Sorry, it is minus 4 here. Okay, so that you have to do. I hope that is clear to you. Now change the signs again. You have got 2 here, plus 4 minus 2, it becomes 2. Now you should multiply a term to this one so as to get 2. So obviously you have to multiply it by 2. So 2 into 1, 2. Then 2 times derivative of 2. Again d square of 2 you get. Derivative of 2 is again 0. D square of 2 is again 0. So it will be not a problem. So minus again 0. So this is how, and whatever you get here, this is your answer for YP. Okay. This is your answer for YP. This is how you are going to solve whenever you have a polynomial equation. So write your YP here. So your YP is equal to x square minus 2x plus 2. Okay. This is the solution for YP. Now write the complete solution. You have got your YC, you have got your YP. Write it together. Write the general solution now. Write the general solution, all of you. So your general solution, y is equal to YC plus YP. Your YC is C1 plus XC2 into e to power minus x. You are done with YC. Next YP is x square minus 2x plus 2. This is the complete solution of this problem. Okay, we'll see one more problem on this. Okay, so that you should get a clear picture or clear idea of how to solve these type of problems. Okay, we'll consider one more problem. Yes, let us come back with one more. Let us solve for one more problem of this type, that is d square plus 5d plus 6 of y is equals to x square. Is it clear to everyone? D square plus 5d plus 6 of y is equals to x square. Okay. Now let us start with the solution. So directly you can write the auxiliary equation from this equation. So let's start with the auxiliary equation only. So the solution goes like this. Auxiliary equation first we'll write. So what should be the auxiliary equation? It is nothing but m square plus 5m plus 6 is equal to 0. Replacing every d by m. So it is m square plus 5m plus 5m plus 6 is equals to 0. Okay, let's work for the roots of this equation. So you can write this as m square plus 2m plus 3m plus 6 is equal to 0. Is it? You can take m common from these two terms, and from these two terms you can take 3 common. So if you take m common, you will get m plus 2. Take 3 common, m plus 2 here is equals to 0. Right? So you have m plus 2 and m plus 3 is equals to 0, or m plus 2 is equal to 0, m plus 3 is equals to 0, right? Or m is equals to minus 2 comma minus 3. These are the two roots, real roots of this equation. Okay, how they are? They are real and distinct. The two real roots which are real and distinct. So since the roots are real and distinct, how will write YC? YC goes as, first use one constant C1, e to the power the first root into x, that is minus 2 into x, plus C2, another constant, into e to the power second root of x, second root into x, which is minus 3 into x. We are done with the half part of this problem. Now come back to YP. So to write YP, again see the given equation itself and separate your y from there. So you get YP is equal to x square divided by d square plus 5d plus 6. Right. So now here comes a point. How will you solve this? Yes, as I told you in my previous problem also, what you are going to do? You are going to, yes, write the numerator in the descending powers of x and write the denominator in the ascending powers of d. Okay, so the numerator has not a problem at all because there is one single term, that is x square, so we cannot do anything to it, so we retain it as it is. But denominator, you see there are three terms, and the term which is independent of d is 6, so that should be written first here, 6. Next, the term having d, one single d, that is this 5d. Finally, we have last here d square, so write it as d square here. So what you are going to do? There is no other term in numerator, single term x square, so write it as it is, but the denominator has three terms, so we are going to write that in the ascending powers of d. So it start with 6 plus 5d plus d square. Now go for division. X square, it is, so let me make a partition over here. Yes, okay, so let us work for that over here. I'll make a partition so that you see it properly, don't mix it with this. Okay, so you have x square here, and draw a line like this. I hope this is clear to all of you. Yes, so yeah, 6 plus 5d plus d square you all are having. Okay, 6 plus 5d plus d square you all are having. Now you should multiply, look at this first term present inside this, it is x square. What is the first term here? 6. Okay, now you should multiply this 6 with such a term so as to get x square. What you should multiply? Okay, so most of you might have not understood the previous part, the previous problem, this part of the previous problem. So I'll once again teach you properly how. Please pay attention. Look at this. You should multiply the term to the 6 so as to get x square. What you should multiply? If you are not getting this point, I'll just suggest you to follow this rule. Just see. You take that term as t. Okay? Take that term as t. Okay? Whatever you should write here, no? That term, let it be t. Okay? So you should multiply t to the 6. 6 into t should be your x square. Is it not? So what should be your t then? X square by 6 or no? Right? So this t should be written here. I hope this is clear to you. See here. You want a term to be multiplied to this 6 so as to get x square. Okay, if you are unable to find it, so do one thing. Just consider that let there be some t there. Okay, we are not going to see what exactly it is. Just take that as t. Okay, t into 6 must be x square. Take it there. T into 6, that is 6t is equal to x square. So what is t? X square by 6. So write it, x square by 6 here. Done. So you got your first term here, see. Okay. Now multiply this to this. So x square by 6 into 6. It becomes what? X square. Write it below. Done. X square by 6 into 6. Gets you what? X square. 6 gets cancelled. You get x square. Now you have to multiply this 5d to this. Now see here, minus, here it is plus sign. Here also it is plus. Plus of plus. It becomes plus 5 times d of x square by 6. Is it clear to you? See, 5 times d of x square by 6. Now what is d? D is derivative, d by dx. Is it not? D by dx. So if you take the derivative, d by dx of x square, derivative of x square with respect to x will be what? 2x divided by 6 or no? If you simplify this. So 2 1s are 2, 2 3s are 6. You have 5x divided by 3. So that comes here. 5x by 3. Is it clear? Yes. Next, you have d square here, right? You have a d square over here, next term. Next you have a d square here. Now you should multiply this d square to this x square by 6. Okay? So it is d square of x square by 6. Now what is d square again? Second derivative, right? Second derivative of x square by 6. So differentiate this x square twice. Derivative of first you keep 1 by x as it is, that is equal to keep 1 by 6 as it is. Then you have to write the second derivative of x square. Okay, second derivative of x square. First derivative of x square will be 2x. Second derivative 2. So you'll simply get 2 after when you simplify this. Okay, so 2 ones are 2, 2 threes are 6. You get simply 1 by 3. Done. Next, you are done with, yes, you have multiplied 6 to x square by 6 plus 5 by 5d to x square by 6 and d square to x square by 6. Every term you have multiplied it. Now nothing is remaining. So now change the signs over here. Cancel this. So minus 5 by 5x by 3 minus 1 by 3. You get it over here. Done? Yes. Now once again, you have to multiply a term to this 6 so as to get minus 5 by 3. Minus 5x by 3. Okay. You should look at the first term present here, minus 5x by 3. Look at the first term present here, it is 6. So you should multiply this 6 a term so as to get minus 5x by 3. So what you should do? I have told you already. Yes, I have told you already what you must do. I'll just do it again for you. Just see here. You consider whatever you have to written here it as t. Okay. T. Okay. T into 6 must be equal to 5x by 3 with negative sign. Minus 5x by 3. Is it not? Let 6 into t is equal to minus 5x by 3. So what should be t? It will be minus 5x by 6 into 3 or minus 5x divided by 18. So the term which should appear over here should be minus 5x by 18. Write that. Minus 5x by 18. Done. Now multiply this minus 5x by 18 to each of the terms written over here. So now what I will do? I'll multiply each of this with this. First 6 over here plus 5d with minus 5x by 18. Then d square with minus 5x by 18. Each of the term I have to multiply that. Okay. Now let's see what we will do. See, here it is 5x by 18 into 6. So if you multiply, obviously you will get minus 5x by 3. Right? Done. Next term is what? Plus 5 into plus 5. So let me do it here clearly so that you should understand. See, you are multiplying, yes, 5d to minus 5x by 18. 5d of minus 5x by 18. It is something like this. Plus 5d of minus 5x by 18. So derivative of x is 1. Minus 5 by 18 is constant. So you'll get minus 25 by 18 over here. Is it not? Derivative of x is 1. So you can write it directly. Minus 25 by 18 over here. Is it clear? Then next what? You have to multiply this d square to minus 5x by 18. So minus 5x by 18, d square of minus 5x by 18. See, first derivative will be 1, but the second derivative, yes, minus 5x by 18, if I take outside, it is d square of x. So you know very well what is d square of x. First derivative will be 1, second derivative will be definitely 0. So need not write any other term over here. You are done with all the terms. Even if you multiply this d square to this, it becomes 0 over here. Okay, so need not do that. You stop it here. Now change the signs. It becomes plus. Here also it becomes plus because it is having minus sign here. Here also it is having minus sign. So it becomes plus here. It becomes plus here. Now these two gets cancelled on adding. Then if you again add these two, what do you get? It is 25 by 18. So what is 25 by 18 minus 1 by 3? What do you get? 18 is the LCM, right? So when you simplify this further, 25 minus 6, it is 19 by 18 you get C. Okay, you get this as 19 by 18. Okay, so you get plus 19 by 18. Okay, now you should see once again the same thing. You have only the single term that is constant over here, and you have 6 plus 5d plus d square, right? So you should multiply a term to this 6 so as to get 19 by 18. So again take 60 is equal to 19 by 18. let whatever term should come here, let that be t. Okay, 60 is equal to 19 by 18. So what should be t? 19 divided by 18, here 6 comes to the denominator. So it will be 19 divided by 48. So it will be 108 here. 16 into 18 into 6, 108. So it will be 19 by 108. So you should multiply. So your t, whatever that is coming here, it should be plus 19 by 108. Is it not? Now multiply that to this term. So 19 by 108 into 6. You have to multiply this to this now. Okay, this to this, again that same rule follows. But look at this, this is a constant term, there is no x, so derivative of this constant term with respect to this d will be 0, second derivative also 0. So the only thing with what you have to do is you have to only multiply the constant which is here with that. So after when you multiply, definitely you will get my plus 19 by 18, change the sign, you get 0 here. Okay, so this is how you solve for the polynomial terms. Okay, so now whatever you have got here, that is your yp. So write our yp, we'll write our yp here. So it is x square by 6 minus 5x by 18 plus 19 by 108. This is how you solve it. Okay, so let us write the complete solution. General solution y is equals to yc plus yp, or yc is c1 into e to power minus 2x plus c2 into e to power minus 3x plus x square by 6 minus 5x by 18 plus 19 by 108. This ends the solution for this problem. Okay, I hope this is clear, but still if you have any doubts, please do ask me in our WhatsApp group. Okay, with this I'll complete this session. I'll give you some more problems on this type as homework in my next session, and then we'll start with variation of parameters and mixed type of problems before that. Okay, till then, thank you.